Hello, good morning, good afternoon, good evening, depending on where you are. We have Matthew from Songcamp and Isaac from Logos DAO doing their workshop on how a headless band built the NFT pack mechanic workshop. Questions, go into the Zoom chat. They'll be more than happy to answer them for you. And with that being said, I'll hand off the mic to our two speakers.
Hi, everyone. Thanks for having us. I'll give just a quick intro and then we'll jump into the topic at hand. But yeah, my name is Matthew, I'm a musician. Been working on Songcamp for the last year and a half. Songcamp, we call it a Web3 laboratory, experimenting at the edges of music and the new internet. And we're here to talk about one of the mechanics in the most recent experiment we ran called Chaos. So yeah, that's me, and here's Isaac.
Hey, I'm Isaac. I'm a developer primarily with Logos DAO, and we got to know the Songcamp folks through just like kind of collaborating in various DAOs. And then at ETH Denver last year, we met up, had coffee, and decided to kind of build this, build the contracts together. So excited to kind of talk through those dynamics and show you how you can fork those and use those for similar dynamics for your own applications.
Cool. So I'll share my screen here, making sure this is viewable by everyone. So yeah, so Chaos is our third kind of flagship experiment in Songcamp. Our experiments take the shape of kind of like a songwriting camp, like a music collaboration experience, kind of glued together with a Web3 hackathon. We ran 3 camps. Our first one was called Genesis about a year and a half ago. Second one was called Electra, and this one was called Chaos. Chaos was a 77-person group, including those musicians and engineers, and then also visual artists, operators, lore builders, storytellers, podcasters, a big group of 77 of us. We're going to walk through a bit. I'll give like a quick overview of the project, but we'll zoom in on the kind of like distribution mechanic, which we're going to talk about here, called Chaos Packs. So yeah, as I said, there were 77 of us. We consider everyone in this project an artist. So we were 77 artists, and we all joined on March 8th of this year into the Songcamp Discord to start our Camp Chaos, with the kind of hypothesis: can we build a headless band called Chaos, where we are all building for this one kind of meta entity called Chaos, release music and art and NFTs through that brand, and then also share in the value flow from that kind of big project as kind of one group moving together. So there's, as you could hear from just the amount of people involved in the different sort of subgroups within that, there's a lot in this project, and there were definitely a lot of domains of it, but we're going to zoom in on mainly like the music and visuals and how those came together, and then how they were packaged within these packs. So just to understand the songwriting camp side of it, there were 45 musicians involved in this camp, broken down into 15 bands. And here you can see how we kind of like broke that down into different houses, kind of all these chaotic mechanics to run this very kind of almost like magical journey into a songwriting camp over 6 weeks. So each house had 4 bands plus an alchemist band, which is just a special kind of band making music a little bit differently. But in the end, 5 bands in each house, 15 bands, and all those bands were essentially given the same task, which was to create one song every 2 weeks. And we're going to repeat that over a 6-week period. So by the end, everyone was part of 3 different bands, part of 3 different songs. And at the end of it, we had what looks like this, 45 songs. So every act, which included each of those 2-week periods, people were collaborating on a song. They collaborated over 3 acts. We ended up with 45 songs. These are the song titles. And then with all of that music, we were not just going to release them as one of ones, but this time create a very large NFT project that included that music in it. So how that was done was, on the visual end, there was a generative or permutive way that the cover artworks were created, much like the PFP projects we're used to in the CryptoPunks style. And these 45 songs were then kind of printed in multitudes of dynamic rarity amongst completely unique generative cover artwork for every single one of these 21,000 pieces. So that creates a big project of a lot of NFTs, a lot of music and visual artwork. minted as NFTs. But instead of just minting those one by one and just like clicking mint and getting one song, the idea came for us to, and here's a little look at the visual aspect of this project. The idea came to actually package these into songs of 4. So the idea was 5,000 packs would be created, 4 songs each, and then you would actually open these packs to get the 4 songs with completely unique cover artwork included. So we kind of have like a bit of a visual of that here. This is where the actual sale is still going. But yeah, this is what the pack looks like. And the idea there was to create, you know, this is so much artwork, so much music. How can we give everyone their almost like personal EP or their personal experience of this with just 4 songs? And Will Jurgens, who is a longstanding member of our community, actually had that first kind of light bulb moment of what if we actually package these into 4? And so Chaos Packs was born. In each of them, when opened, 4 music NFTs are revealed at random with their own unique cover artwork. Each of these 4 is a unique song of the 45 songs available. So you get 4 songs per pack. And you have the choice to either open your pack or keep it closed. So this was the sort of idea of how we were packaging together this sort of chaotic art that was being created in this camp. And that is when Isaac came in to figure out how in the world we were actually going to do this. So I'll pass to you, Isaac.
Thanks. So we initially we discussed a lot of different options for how to actually distribute these songs randomly into packs. Yes, if you go back to the previous visual, and so like after all 21,000, after all, actually, so it was split into 2. There's the 21,000 because 1,000 were generated to go to the actual camp participants themselves, and those actually had royalties attached to them from the rest of the collection. But the 20,000 are the ones that came from packs. So those 20,000 were randomly distributed between like token IDs 1,000 and 21,000. And then they were chopped up into like sets of 4 and distributed into packs. And then those packs were opened in random orders. So it's kind of like multiple levels of shuffling. We discussed a bunch of different ways of potentially doing this randomness, ranging from like having just, you know, different song, different like token IDs that would get generated, different like cases where like when you actually open the pack, it would like kind of randomly decide based on like modular arithmetic, like which song ID it got. But what we actually ended up with was just like distributing all of the songs based on rarities along that kind of continuum of 20,000 songs, and then chopping them up into pieces, and then having the pack numbers randomly choose a different pack from that continuum. And so once we decided on that mechanic, there was actually a bunch of different ways to handle pack opening. And I simulated a bunch of the different ones to see which one would be most gas efficient. So if you go to the next slide, this is like from Excel, just like a graph of the different pack opening dynamics. So the most naive implementation, which I called guess and check, was like get a semi-random number between 1 and 5,000, and if it has not been opened yet, then that's the pack you got. And so like every single time that a pack was opened, it might give you a number between 1 and 5,000. And if it collided, meaning like, and then you would, once it's open, then you mark it as open. And so you, in the beginning, very small chance of collisions because like there's 5,000 different potential packs. You open one, if it has not been opened yet, that's the pack you get. Then you do that for the next one and the next one. And then if it detects a collision, then it like increments up to the next pack. So this was fine, as you can see, kind of between packs 1 and like 4,000 or something. But like it starts getting more and more chaotic, which is kind of funny. Like part of me actually kind of liked this dynamic because it was chaotic, where as you got closer and closer to the end, it got more and more expensive to open the packs because there was a higher chance of getting a collision and having to like increment in a loop to find an unopened pack. And so that's why that blue line is like the most naive implementation, which is cheap in the beginning, but gets like really expensive towards the end. So I then was experimenting with different ones where kind of split the 5,000 packs into a tree where you could check to see if a specific branch of the tree was filled. And so that like it was still like kind of a naive guess and check algorithm, but it was made slightly better, or not necessarily better, but more consistent due to the fact that like we could limit the amount of bad potential choices. And so in the worst case, you were going to have like 200 loops of a for loop rather than the worst case being 5,000 loops of a for loop. So you can see that that light green color was like twice as about like 1.5 times more expensive in the beginning, but then it was like pretty consistent throughout, except that it was actually a bit more chaotic. So after I tried a couple of these methods, we actually reached out to the Zora team and wanted to get some input on like potential ways to do this algorithm. And one of the developers was like, hey, I actually wrote code that has done this already. And so he shared this code with me, which used this like select and this like this permutation algorithm, which would allow you to like select an integer from a set and then remove it from the set so that you could never get a collision again. And so that's that yellow line. This is like the Zora algorithm that we implemented to see how efficient that was. But then he said that like he thought that there was actually an even better way to do it, which used a mapping instead of an array. And that was that dark green. And so those are like so this is just kind of interesting to see the different choices that you make with regards to like implementing these different algorithms have very different implications on gas. We ultimately ended up going with that dark green line, which kept gas for opening consistently around 140,000, which was pretty cheap. Like that's still like way cheaper than a normal like NFT mint. And in this case, you're getting 4 NFTs. Let's see, what's the next graph? Oh, another thing I did was just to make sure that there was no sort of like weird biases in the algorithm with regards to like when certain packs were opened. This is just a blob of uncorrelated stuff, which is good. And so what I was checking here is like as I opened pack numbers, which group of songs got assigned. And since like there's no discernible pattern here, I thought, okay, this algorithm is pretty good. And there was no chance of like, there was no information that somebody could obtain about like when they were going to open their pack, which songs they were going to get. Yeah, so the nice thing about all this is I'll share in a bit. This is all open source. So if you're curious about, and you can even look through my Git history and see all my like crappy initial implementations before like the final one that I like. So it's all on like the Songcamp GitHub. And I think towards the end of this, I might have a chance to kind of walk you through and find some of those. Yeah. So if you go to contracts on this page, batch shuffle, this is my fork of the logic that the Zora team contributed. So this allows you, this is kind of a combination of that logic and some logic from Adam Fuller, who did this like Martian Premier League NFT project, which was in turn based on, I think, Tubby Cats or something. So the NFT space is full of borrowed code. So this is like a bunch of different people contributing to create this like batch shuffling algorithm to make it so that you can have a different shuffled ID from a discrete set. So in this case, in the constructor, you set the available count, which in our case was 5,000, the batch size, which was 4, and the start shuffle ID, which is just like, 0 or 1, depending on how you want to do it. And then what you can do is use this inside of the pack opening logic contract to make sure that you're getting a random pack along that continuum of pre-shuffled songs. So if you go up a couple levels, you can, in this level, you can see chaos packs and then chaos songs. So packs are the unopened NFTs. And then you can see in songs, that's where the dynamic is of actually opening, which burns the pack and then mints 4 songs and assigns this like shuffled offset. And then if you go up one level to Camp Chaos, there's a full, this is a hard hat development suite. So if you go to test, you can see I have this end to end, the first file there. That's probably the best place to look if you just want to see like how this stuff gets deployed, and then how it gets open. So this is a full, if you run this, it'll probably take a few minutes to run because this actually goes through and opens like mints 5,000 packs and then opens every single one. You don't generally need to do this. You can make it smaller. But this is like a complete end-to-end script, which will show you how all the dynamics work. And then if you go up a couple levels to tasks, you can see there's this actually has a lot of really useful stuff around generating like DNA and images. This is a fork of Headless, but I added a bunch of nice utility functions. Like I separated the DNA generation from the image generation, because like if you do this at the same time and you're trying to do like 10,000 things, your computer it'll take like 7 hours for your computer to do this. And in this case, the generate DNA script will like run in 30 seconds. And so you can kind of do that first and then generate the images and also generate the JSON metadata. I've just kind of split that out into different functions in case you need to like mess with stuff. And that way you don't have to like run a 7-hour script every time you want to like generate your stuff. So all of that stuff is in here. You can also like ping me if you're interested in understanding how to do it. There's also some like vestigial code in here. I was trying to parallelize the process, generate images parallel and workers. But the underlying library that Headless uses called Canvas is not compatible with parallelizing. And so don't go down that rabbit hole. I already tried, it doesn't work. But you can see what it would look like if it did work. And maybe Canvas will someday update their library to work in parallel, because right now it does not, and it's really slow. So there you go.
Cool. And maybe just to, I'm not muted, eh? You can hear me. Just to put this all together, and then we could maybe take some questions. This is the website. This is how you actually interact with it. You have all the 45 songs we were talking about here, listenable on the site, and with some example cover artwork. And then the actual mint process is minting packs. And once you mint packs, the packs enter your chaos inventory, which I'm not connected right now. Am I signed in? Let's see. I'm not even signed in. Okay, well, can I sign in without you guys seeing what I do?
Yeah, no, MetaMask, or it might, I don't know. We can see you typing in your password. But...
Don't fish me, anyone, please.
Just paste your seed phrase in the chats, and we'll send you some packs.
Okay, here. So here you can actually see the beautiful artwork here. Artwork done by JGap, designed by Losing My Ego, front end built by Daniel Rojkind. And we have here like the ability to actually open your packs, which, yeah, as Isaac was saying, burns the pack and then mints those 4 songs. And then you start filling your chaos inventory down here with the songs that you've minted and the cover artwork you've received from those. So that, yeah, that kind of brings it all together. And that's what we wanted to share with you guys today.
Nice. Any questions?
It looks like Helios just sent something in the chat.
Yeah, this would pair really well with some kind of like loot crate kind of thing. Actually, speaking of loot, like I think it'd be kind of fun if somebody pair this up with something in the loot ecosystem in general, where you can like shuffle you could like shuffle any sort of in-game things into this thing in the way that we shuffled the songs. And then you can give people packs to open them, because like there's actually no requirement for all the packs to be sold before people start opening. So like you could create this, you could create like let's imagine that you're, I don't know, Fortnite or something, and you have like a season full of like in-game items. You could create those, allow people to buy them, or even like drop packs on people periodically throughout a season, and allow them to open it and get a random pack of 4 things. And the only knowledge that people have is like what's already been claimed, but it doesn't. There's no indication on like what you're going to get next. So I think that there's a lot of potential to use these same dynamics and algorithms in general, like kind of NFT game dynamics.
Cool. If anyone else has any questions or anything you want to discuss, definitely feel free to use the Zoom chat or even come off mute yourself to say it live.
I could also ask a question for Isaac, because I'd be just interested if like you were to go and do this again, would you do anything differently? And I guess one, like maybe a second part to that question, which is one maybe like potential idea I think we've spoken about a little bit before of like including like a chain link random number generator or something like that.
Oh yeah, so the RNG part of this is like a very simple implementation. It's technically gameable because it uses like previous block hash. And so if you were to use something like Flashbots, or if you were like had control of a miner, you could wait to open a pack until you had an optimal previous block hash. It's like hard to, or it's like not technically hard to exploit. It would take time to kind of like sit there and wait until you open the pack that you want. But this was like, in my mind, an acceptable complexity trade-off for this type of application. Previous block hash is good enough. But there's a version of this that you could do using Chainlink VRF, where you could, when you would click, you would do open pack, and when you opened a pack, it would request a true random number from Chainlink's Oracle. And then when that answer was available, because Chainlink oracles in this case act as kind of like a question and answer, you would have to hit open pack, which asks the question, hey, Chainlink, which pack am I going to get? And then their node replies, and that's when your pack would be revealed. And in that case, it is completely not gameable. So something that I might experiment with, maybe, I don't know if Chainlink is sponsoring, but they're I think it might, if somebody wanted to like fork this and add the Chainlink VRF, that would be a really cool project. Other than that, I'm trying to think if there's anything else that I would change about the contract. Everything came together pretty smoothly. It actually uses ERC 721A, and that's why opening a pack is so cheap. It's because like when you open a pack, you're getting 4 consecutive songs from that distribution. And so it's only charging you for 1 mint, but the contract marks you as getting 4 consecutive things. So then if you want to transfer one, then it like then it identifies like who that you own, like which ones you own in the middle of that chunk of 4. But it uses ERC 721A to make it so that pack opening costs 150,000 gas, not like 600,000 gas.
Awesome. I guess if that's it for questions, we can end the workshop here today. Thank you so much, Matt and Isaac, for taking the time to do a workshop for Metabolism. I'm super excited to see like what the hackers learn from this and what they're going to be building for their projects. And to you hackers, thank you so much for tuning into the workshop. We do have a couple more workshops today, so hope to see all of your faces there as well. And other than that, I hope everyone has a great rest of your day.
Thanks, everyone.
Thanks. See you.
Get forking.